Today we're looking at finding the length of a line segment. Another word for finding the length, so for example, if you wanted to find the length from A to B, you're finding the distance, right? Okay, so we're going to be using something called the distance formula. And I'm just going to show you the reasoning behind it and why this formula is developed, okay? I have a line that's drawn from A to B, and I've just plotted it on a grid here. Okay, so we know that this is located at 0, 8, and this is located at 5, 16. I need to know the length from A to B. How many of you remember something that you use when you're working with right angle triangles? What is this referred to as in a right angle triangle? Yes. The hypotenuse, which is C, with Pythagorean theorem, right? So distance formula is actually related to Pythagorean theorem. I'm just going to show you why. What is Pythagorean theorem? A squared plus B squared equals C squared. Let's say that this is A and this is B. Looking at this graph here, how would I figure out A? I want to know the distance from here to here. So from here to here, how do I figure that out? Pardon? From 0 to 5. It would be 5 minus 0, right? Okay, and what about from here to here? So from 8 to 16, how do you find the difference between that, the distance? 16 take away 8. Okay, what's 16 take away 8? And 5 take away nothing is 5. That, what do we have to do with those values to plug into Pythagorean theorem? We have to square them, exactly. So what we're actually doing, and I'll show you on the next page. Okay, I had two coordinates to start with. I had x and y and x and y. I subtracted my x values to get A, and then I subtracted my y values to get B, right? We subtracted the y values, okay, plus we're subtracting the y values. But then what do we have to do with that? What is Pythagorean theorem? We square those numbers, right? But then to get C, what do you have to do at the very end, Irvin?
Square root.
Square root, that's the distance formula. That will give us the distance from here to here. To find the distance, let's call this D, because it uses the variable D.
No, I want C, please.
To find,
D's better.
so to find the distance from, let's say in this example, A to B, well, if you're given the coordinates, all you have to do is subtract the x values, then square it, and add this to, you have to subtract the y values, square it, and then at the very end, once you simplify that, you have to follow BEDMAS, you find the square root of those values, and that's the answer. That will give us the distance from A to B. So if you're asked to find the distance from P to Q without graphing, well, I know that these are both coordinates, so let's call this x1, y1, and I'll label this as x2, y2. As long as I use 2 for the second coordinate and 1 for the first coordinate, it doesn't matter if I called P x2 and y2, okay? Then we're just going to plug these into the formula. So distance formula, x2 minus x1 squared plus y2 minus y1 squared. Then we find the square root. So what's x2? What's x2?
X2 looks like an X1.
Sorry, x2 is 3 minus, what's x1? Negative 4. Watch your signs. All of that is to be squared, so we have to do this in order. Plus, what's y2? 1 minus, what's y1? 7. All of that is to be squared. Keep simplifying. What is 3 take away a negative 4? Good. 7 squared plus, what's 1 take away 7? Negative 6 squared. Keep simplifying. 7 squared? 49. Plus, what's negative 6 times negative 6? Positive 36. Good. What's 49 plus 36?
Negative 13.
It's over.
49
The author.
plus 36 is 85. The square root of 85, we're going to round it. Round it to 1 decimal place. Is approximately equal to 9.2. Therefore, the distance from PQ is approximately 9.2 units. We don't know the units. That's it.
Made with Doodlecast Pro.